Today, we're going to dive into a really powerful idea from cognitive science that's kind of secretly shaping everything, from how scientists measure the universe, all the way down to how you and I make sense of reality itself. It's a concept that, and this is the wild part, finds perfect sense in being just a little bit vague. So, let's explore how it all works.
But first, let me just ask you a question, a really simple one. Think about it. Is anything ever truly 100% perfectly identical to anything else? Two snowflakes, two grains of sand, even two moments in time? This question, as simple as it sounds, actually reveals a huge problem our minds have to solve every single second of every day.
For example, take the color red. In our heads, red feels like a solid thing, a clear category. But in the real world, it's just a smooth, continuous spectrum of light wavelengths. There's no hard line where orange stops and red begins. So how on earth does our brain take all that messy reality and give us this one neat, useful idea of red? Okay, so that gap right there, the one between our clean concepts and the continuous flow of the real world, that's exactly where our journey begins. We've got to look beyond this idea that our concepts are these perfect single points of meaning. See, our brains are built on this absolutely brilliant shortcut. We group things together that are, well, similar enough. We have to create these categories to manage a world that is just infinitely complex. I mean, without this ability, every single experience you had would be totally unique and completely overwhelming. We just couldn't learn or function. So what do we call this mental shortcut? Well, cognitive science and logic actually give us a fantastic name for this tool, and it's called the interval of abstraction. And here it is, the core idea of this whole explainer. A concept isn't some tiny, perfect pinprick of meaning. No, it's more like a range, a flexible container. The concept of red isn't one single, specific wavelength of light. It's the interval that includes everything from crimson to scarlet to cherry. Most of us intuitively feel that for a word to mean something, it has to point to one exact thing. We sort of imagine our concepts are meant to be incredibly sharp, crystal clear, and absolute. But the reality is so much more interesting and, frankly, more powerful. Our concepts are actually way more like these brackets, a defiled but flexible range. And that flexibility, that's not a flaw. It's their greatest strength. It's what lets us apply one single idea to tons of slightly different situations. Now, I know what you might be thinking. This all sounds a little fuzzy, a little imprecise. But here's the crazy part, the paradox of it all. This seemingly imperfect way of thinking is exactly what allows us to achieve incredible precision, especially in science. And the research behind this just nails it. Think about it. Science doesn't get precise by ignoring uncertainty. It gets precise by defining it. It's all about drawing those brackets and saying, okay, the truth is somewhere in here. And this table just shows it perfectly. Look at the naive view. 10.0 meters. It looks perfect, doesn't it? But it's hiding its own uncertainty. The truly scientific, the gnosiologically precise statement is to say the measurement is actually somewhere between 9.9 and 10.1 meters. It's more honest, and because of that, it's actually more precise. So here's the real takeaway for this section. True precision isn't about claiming you hit some impossibly small, perfect bullseye. It's about knowing the exact boundaries of your target. It's about clearly defining the size of your interval. Okay, so we've seen how this works for physical measurements. Now let's take it a step further and apply it to something even more fundamental, the very idea of sameness, or identity. So the interval actually helps us understand that there are two different ways we decide things are the same. Sometimes it's an active choice. We decide to group two different things under one label, like calling two very different looking chairs both chairs. That's identification. But other times, two things are just so close together that our senses literally can't tell them apart, like two shades of paint that look identical. That's indistinguishability. And what's so cool about this framework is that it lets us hold two ideas in our head that seem to totally contradict each other. Some concepts, right, like the mathematical idea of the number 2, they can have an absolute perfect meaning. But most of our concepts, chair, red, even our idea of who we are from one day to the next, they're relative. Their meaning only makes sense within a certain interval, a certain tolerated range of difference. All right, this brings us to our final section, and honestly, the biggest takeaway of all.
This abstract tool isn't just for scientists or philosophers. It is the fundamental process that every single one of us uses to build our entire picture of the world.
Every moment of every day, your mind is performing this incredible act of translation. It's building a bridge over a massive gap between two completely different kinds of worlds. On one side, you've got World 1, and this is just the raw, unfiltered, continuous flood of information hitting your senses. It's a chaotic stream of light and sound and feelings with no built-in labels or breaks. It's just pure experience. And then on the other side, you've got World 2. This is the world inside your mind. It's all neat. It's organized. It's made of separate, distinct concepts like dog, car, happy, sad. It's structured. It makes sense. The great mathematician Henri Poincaré actually had a name for this. He called the leap from that messy World 1 to the organized World 2 the discontinuity jump. And the interval of abstraction? Well, that's the engine. That's the tool that makes that incredible jump possible. It's how we turn chaos into clarity. So every concept you hold, every idea in your head is an interval. And all of these intervals, all linked together, they form what the research calls our gnosiological universum, which I know is a super technical term for something deeply personal. Your unique, subjective map of reality itself. Which leaves us with one final, kind of mind-bending question to think about. If our entire understanding of the world is built on these flexible ranges, these intervals, then who decides how wide they are? In a world that's really just a bunch of continuous spectrums, where do we, or where should we draw the line?